Welcome to my lecture on the root test. Okay, the root test is a test for divergence or convergence of a series. And the first thing that we need to do is to compute this. Okay, so consider the series summation from n equals 1 to infinity of a sub n and calculate this limit. It's the nth root of absolute value of a sub n. And we're going to call this limit L. Okay. There are three scenarios just like the ratio test for L. Here's scenario 1. If L is less than 1, the series is absolutely convergent. Okay. If L is bigger than 1, the series a sub n is divergent. And the third scenario is if L is equal to 1, there is no information. So you need to use another test. And there's a long list of tests for convergence or divergence. Okay. So let's consider a few examples. Is the series is this convergent or divergent? Now, if we're just asked this question, convergence or divergence, we could use the alternating series test. If it said, is it absolutely convergent, we couldn't use it. Okay. So, we have the option of using the root test or the alternating series test on this series. But for sake of example, I'm going to answer it using the root test. So here, a sub n, and I'll put it in absolute values, is just going to be 1 over 5 to the n. And we just need to compute this limit as n goes to infinity of this nth root of 1 over 5 to the n. Well, remember the nth root is the same as this, to the power of 1 over n, and then I have 5 to the nth power, so they're going to cancel each other's out using the properties of exponents. So this will be 1/5, and our final answer for the limit is 1/5, and this is less than 1. So we're in case 1 at the top here. Hence, by the root test, and by the way, this is the limit L by the root test, since L is 1/5, which is less than 1, the series summation from n equals 1 to infinity of minus 1 to the n over 5 to the n is absolutely convergent. And absolutely convergent means that if I ignore the negative sign, I take the absolute value of each term, that converges. That series converges. Let me give you one more example. Is this series convergent? Excuse me, I want to put it to the nth power. Convergent or divergent? Well, we're going to answer this using the root test. And with this root test, a sub n is going to be 3n plus 1 over 2n plus 3. And so we're going to do this. We're going to compute this limit as n goes to infinity of this nth root of absolute value of a sub n. The absolute value isn't needed because every term is positive. And I'm going to convert the nth power to the 1 over n like that. And I apologize, I missed one thing. A sub n needs the exponent n there. Okay, so 3n plus 1 over 2n plus 3. And this thing here is to the nth power, and it's to the 1 over nth power. So using the powers of exponents, I'm going to get 3 over n plus 1 over 2n plus 3 to the power of n over n. So that's just going to be 1. Then, if I want to compute this limit, right, using L'Hopital's rule, I can just differentiate the top, that'll be a 3, and differentiate the bottom, that'll be a 2, and my final answer will be 3/2, and that's my limit. This happens to be bigger than 1, so going up here, I see that I fall into case 2 here, and so the series is divergent. Okay, so by the root test, since L is 3/2, and that's bigger than 1, the series is divergent. Okay, so just to recap, what I want you to understand is the statement of the root test. Okay, everything from here to here. Okay, so know that we need to take the nth root of the terms in the sequence and compute its limit as n goes to infinity. Then we need to decide if that limit's less than 1. If it's less than 1, it converges. If it's bigger than 1, it's divergent. If it's equal to 1, there's no info. Okay, this is very similar to the ratio test. Okay, but do not confuse these statements with the limit comparison test. That one is different. Then I want you to understand how we applied this in these examples, and understand this example at the top and then this next example right here. Okay, thank you for joining me.